Hello everyone. Write down electromagnetic waves. Now, what are electromagnetic waves? Maybe you have a little bit of an idea about these things. Waves in which electric field and magnetic field oscillate are called electromagnetic waves. In 11th, you have seen mechanical waves. In mechanical waves, for example, sound wave, it's the air molecules which oscillate. When we talk about electromagnetic waves, it's the electric field and the magnetic field. These are the two things which oscillate. So let's start with this statement. In electromagnetic waves, write down the statement. In electromagnetic waves, electric field and magnetic field oscillate at a given position Now when you say oscillate at a given position, what does it mean? It means strength and direction of electric field and magnetic field, it continuously changes. The strength is something which is oscillating along with the direction part. Write down this. That is, at any given position, that is, at any given position, strength inside the bracket magnitude, strength and direction of electric field and magnetic field continuously changes with respect to time. At any point, strength and direction of electric field and magnetic field continuously changes with respect to time. I hope you remember equation of a transverse wave from 11th, and that equation was y equals to a sine omega t minus kx. Or maybe you remember this, a sine omega t minus x upon v. This and this, they are same. Multiply omega inside. When you multiply omega inside, the term omega upon v is k. And this, what is omega? Omega is 2 pi upon t multiplied by v. V multiplied by t. This is called wavelength. This is 2 pi upon lambda. This k is called angular wave number. Omega, you know, is angular frequency. V is velocity of the wave. At any position x, transverse displacement of a particle is given by y. So, if we draw a y versus x graph for a transverse wave, it looks like this. At any distance x from the source, this is the position of source at origin, S for source. At distance x, if you go, this particle at time t is found over here at time t. This height is called y. What is the relation between y and x? This is the relation between y and x, which is called equation of a transverse wave. Now, in electromagnetic waves, it's the electric field and the magnetic field which oscillates, and therefore we will simply replace y with e. X will remain x only. If you replace y with e, then your equation becomes this: E equals to E naught sine omega t minus kx. What is a amplitude? Amplitude means maximum displacement from the mean position. This particle, it can oscillate like this. Its maximum displacement is called amplitude. What is E naught? Maximum value of electric field at a given point. That is called what? E naught. What is this? Electric field at any given time t at a given position x. At one point, at some time, this whole thing will become what? 90, and E will become what? E naught, maximum. When this whole thing becomes 180, sine 180 is what? 0. Electric field will become what? 0. And so on. That's how electric field will change with respect to time. Now, if we write magnetic field, then this B is B naught sine omega t minus kx. There is a very interesting thing involved in this, and we'll write there is a statement also later on. This whole thing is called phase. Phase. Phase of electric field and magnetic field in electromagnetic waves is always same. That means if electric field is maximum at a given position, then magnetic field at that position at that very moment will also be what? Maximum. If electric field is 0, magnetic field will also be 0. We'll write this later on. This is E, this is B. If I ask you to draw a graph of E and B, this is a graph. You will simply replace Y with E and your X remains what? Same. The maximum of Y, which was at this place and is represented by A, this time this A will be E naught. If you wish, you can draw a separate graph, a similar graph, and in that graph replace y with E. The y which you see is now E, electric field. This is the maximum of electric field at this particular time, at time t. This position has maximum electric field. This position has zero electric field. I will discuss this part also, but right now note down everything. And one more thing, this scale which you see is omega upon v. What is v? Velocity of wave. And what is the velocity of an electromagnetic wave? Electromagnetic waves, they move with the speed of light, and therefore this scale is omega upon c. C for speed of light. But whatever it is always 2 pi upon lambda. What is lambda? Wavelength of a given electromagnetic wave. Note down this much information first. Write down the meaning of this equation. E is electric field at a given time t at a given position x. X is distance of the given position from the source. Source is considered at the origin. Source is considered at the origin. Write down about E naught. E naught is maximum strength of electric field at any point. At any point. Right now this electric field is zero, but it will not remain zero forever. At this place electric field will change just like this. Suppose this blue marker represents electric field. Right now electric field is zero, and then it will increase. It will increase, becomes maximum E naught, and then starts decreasing, becomes zero, and then it changes direction, becomes maximum in the opposite direction, decreases back to zero. So that's how electric field is going to oscillate. when you talk about a particle is leaving this position, it will oscillate between these two outside ranges, A and minus A. In case of electric field, nothing is leaving. Electric field at any point, if somebody is looking at this place, you will find that electric field is 1, then it becomes 2, then it becomes 3. Let's say 3 is the maximum. Then electric field at this place only will decrease. 2, 1, 0, and then it will reverse its direction, minus 1. Minus 1 means strength is 1, direction is what? In the opposite sense. Minus 1, minus 2, minus 3, minus 2, minus 1, 0. And then again 1, 2, 3, 2, 1, and so on. So remember meaning of this equation, E is what? Instantaneous value of electric field at any given position. Maximum of electric field. Write down omega. Omega is angular frequency. Omega is angular frequency of the electromagnetic wave. And I hope you know that omega is also 2 pi f, where f is natural frequency. When you say natural frequency, unit is hertz. When you say omega, unit is radians per second. Note down this. Write down properties of electromagnetic waves. Properties of electromagnetic waves. First, electromagnetic waves are non-mechanical waves. Electromagnetic waves are non-mechanical waves. That is, no medium is required. That is, no medium is required for their propagation. No medium is required for their propagation. Sound, it needs medium, but light, it doesn't need any medium. It can even travel in vacuum. Second property, electromagnetic waves are transverse in nature. Electromagnetic waves are transverse in nature. That is, electric field and magnetic field, oscillate perpendicular to the direction of propagation. electric field and magnetic field oscillate perpendicular to the direction of propagation. I will show this thing in a figure, but write down the third point also before that. Third point, electric field and magnetic field, electric field component and magnetic field component are always perpendicular to each other. Electric field component and magnetic field component are always perpendicular to each other. Suppose an electromagnetic wave, for example light, is traveling along x-axis. Then at any place electric field is perpendicular to what? Direction of propagation. So this is E. At this place, what is the direction of magnetic field? Direction of magnetic field will be shown by a dot or cross. It should be perpendicular to what? Direction of propagation, also perpendicular to what? Electric field. So this is X, this is E, this is B. If this is E, then this will be B. Now, in this part, this is X-axis, this is Y-axis, and this is what? Z-axis. You can also draw a view in this form. If I say that dot is the direction of propagation, dot represents x-axis, then this dot basically gives you direction of C. Light is traveling this way. If electric field oscillates at this place in this direction, this is E. I've shown both up and down arrows because electric field will be up and after some time it will also be down. Then magnetic field is going to oscillate like this. This is your magnetic field. And the dot, this dot, it tells you, it gives you x-axis, which represents, which is giving you direction of what? Speed. This E is along the y-axis. This B is along the z-axis. So what is all? This is C. This is electric field component and this is your magnetic field component. All three are mutually perpendicular. All three are mutually perpendicular. C, E and B. This is the side view and this is the front view. Put on both these figures. Right now, next point. At any point, electric field and magnetic field, at any point, electric field and magnetic field are always in same phase. At any point, electric field and magnetic field are always in same phase. That is if at any point electric field is zero, at any point if electric field is zero, magnetic field will also be zero. Similarly, if at any point electric field is maximum, then magnetic field will also be maximum at that point. This is the meaning of phase. When you say things are in same phase, it means this. Next point, ratio of E and B, is always a constant. Ratio of E and B is always a constant, and let me see if you know this much or not. What is this constant called? Ratio of E and B for electromagnetic wave is a constant. What is this constant called? Is there anyone who can answer this? Good. One response. At any ratio of E and B is a constant, and this constant gives us speed of electromagnetic wave in that medium. And this ratio gives us speed of electromagnetic wave in that medium. So when you go for E upon B, this is same as E naught upon B naught. They are in same phase and therefore sine and sine they get cancelled. This gives us C, speed of light or electromagnetic wave in that given medium. For vacuum, this is simply 1 upon root over epsilon 0 mu naught. E upon B is 1 upon root epsilon 0 mu naught. This will be 3 into 10 to the power 8 meters per second. This is for vacuum. For C in some other medium, this thing is 1 upon root over epsilon of medium and mu of that medium, which is nothing but epsilon r multiplied by epsilon naught mu r multiplied by mu naught. What is epsilon r? Epsilon of medium divided by epsilon 0, which you know as dielectric constant. Similarly, relative permeability mu r is mu of a medium divided by mu or permeability of vacuum. Note down this. Now let's see how do we produce electromagnetic waves. And for that, we will use LC oscillations. This will give us some interesting results especially for competitive examinations. Write down LC oscillations. This is an inductor. And we have a capacitor. This is the switch, and initially capacitor has charge Q naught. Switch is open. This is your inductor, and a capacitor switch is open. When you close the switch, this capacitor is going to discharge itself. These electrons will start moving and want to arrive at the positive plate the moment you connect this switch. So when you connect the switch, after connecting the switch at time t, this is before connecting the switch, at t equals to 0, you close the switch, and then after time t, we are drawing this figure. Due to discharging, now charge which is left is Q, and charge which is left on this plate is what? Minus Q. Now, if I ask you what is the direction of current, you can do what? At least for now, just consider that positive plate is like positive terminal of the battery. If this is a positive terminal, then current is going to flow like this. This is I. That's for your understanding. Positive plate behaves as the positive terminal of the battery, and you can decide easily direction of current. So what is Q? Charge on the capacitor at time t. What is I? Current in the capacitor at time t. Now, this Q is continuously changing. Right now it is decreasing. If Q is decreasing, then just understand this way, as if this battery is losing its power. If battery is losing its power, then this I is also going to change. And if I is going to change, then in this inductor an EMF will be present. Induced EMF. The moment you change I, flux changes. Phi, it was what? Li. So if you change the I, flux changes, and because of that flux change, there will be an induced EMF, which is minus of d phi by dt. Now tell me this, what type of EMF will be present in this inductor, this type or this type? Type A or type B for this particular setup starting from Q naught. Q naught is the maximum charge, and the moment you close the switch, charge starts decreasing, and we found this figure. In this figure, if I ask you what type of EMF polarity will be present, type A or type B, given by this minus of d phi by dt, which polarity do you think is correct one, A or B? Answer this. Go down this much and try to answer this part. Well, except one, all others are saying B. Let's see B is correct or not. If you say this is the polarity, then the setup looks like this. How easy it was to decide whether it's A or B. Look here. Positive, negative. If you say this, negative, positive, which means what? Positive means high, negative means low. So as I move from this point to this point, I move from high to low. And if you say inductor gets this type of polarity, then you are saying what? This is low and this is high. Negative is low, positive is what? High. So as you move from this point to this point, you're saying that you're moving from low to high. But point potential technique tells us that this is same as this. This is same as this. So at the bottom you're saying you're moving from high to low. At the top you're saying you're moving from low to high. But they both represent same potential, and these two also represent what? Same potential. And therefore B is not correct. This is not the correct thing. What is the correct one? This is the correct one. A simple objective profile. And if this is Q, this is minus Q, then this is the current. Induced EMF will be this. Now tell me, as I told you, we started from this position. Close the switch. Close the switch means Q is decreasing. If Q is decreasing, then now answer this. What happens to I? This I, is it increasing or decreasing? What do you think? Note down this, make a cross. This is the correct polarity. High, low, high, low. Now once you have decided the polarity, what is happening with this current I? Is it increasing or decreasing at this moment? This is the next objective profile. I've got two responses and they both are saying that decreasing. But I hope you remember Lange's law. What is Lange's law? Induced EMF is going to oppose cause of its production. What is cause of production? I. If you say that I is decreasing, then induced EMF will try to increase it. But we have already decided that this is the polarity. What this polarity does, it is going to oppose I. If it is opposing I, that means right now in this circuit, I is increasing. With the help of point potential technique, basically Kirchhoff's second law, we have decided what happens to I when Q decreases and the polarity part. Listen again. This is the polarity. I said because of Kirchhoff. Why because of Kirchhoff? Start from this. Let's say this is, just for the time being, say this is 10. And this is, just for your understanding, let me take a different value. Although they both will be same because of point potential technique. But just for the time being, assume that this is 12. So when I say this is Kirchhoff, what is Kirchhoff's second law? Potential difference in a closed loop is always what? 0. Start from this point. Negative to positive. Rise. Rise is taken negative. Negative to positive. Rise. Minus 12. You started from this. When you complete full circle in a closed loop, it's coming what? Rise and rise. Kirchhoff says this thing should be 0, but it is not, and therefore is not correct. So what is correct? This is correct. This is 10. This is 10. You start from this position and you complete one closed loop. From this to this, positive to negative drop. Drop is taken plus 10. Negative to positive rise. Rise is taken minus 10. 10 minus 10 is coming what? 0. So this concept of low and high, high and low is nothing but Kirchhoff. If you wish, you can note down these two things as a side note, that why you cannot have a polarity like this if left plate is positively charged. As long as left plate is positively charged, that's how the polarity will be there. If this is the polarity, then this polarity is opposing what? I. Since I is flowing in this direction, you have to oppose it. It means this I is increasing. And then after some time, I'll give you another logic for Q decreasing and I increasing. Why this can be the only solution for this type of thing. Put on this much. By the way, those of you who understand that Q, if is decreasing, then I must increase, write down yes in the comment box. Now, So let's write Kirchhoff's second law for this. This part, this EMF is L di by dt. When you differentiate this, you get what? Minus of L di by dt. But we are not using negative sign because we have already decided direction of polarity. Negative sign, it tells us from Lenz's law that induced EMF is going to oppose. We have already decided that. It's opposing. Because if you put a negative sign again, and if you have shown this polarity, and you say that this is minus of L di by dt, then you are basically inverting this battery. So this is the magnitude of this battery, which is L di by dt. Now, how do you write Kirchhoff's second law for this closed loop? Drop, which is positive, L di by dt. Negative to positive, rise. Rise is taken negative, minus of Q by C. Charge on the capacitor is Q, its capacitance is C. This is rise, loop closed, which is what? 0. Just few seconds before I told you that L di by dt is Q by C. I hope you remember, right here, it was written 10 minus 10 equals to 0. What is that? 10 equals to 10. So L di by dt is coming Q by C. Now what is I? I is dq by dt. I is what? dq by dt. That's what many people think. But no, I is not dq by dt. I is minus of dq by dt. Why? Because Q is decreasing. If Q is decreasing and I use dq by dt, then this number will be negative. Q is decreasing and therefore dq by dt will be negative. If I is negative, that means this is not the correct direction. But I know that since this plate is positive, this is the correct direction. So I is what? Minus of dq by dt. What is minus of dq by dt? Minus of minus, which basically is a positive number. Negative of something which is already negative gives you what? A positive value. So in this, I, remember, is not dq by dt, is plus dq by dt. Now, many times people get correct final result because they will be using minus of L di by dt here by mistake, and then again they will be using dq by dt by mistake, and you are committing two mistakes, and by chance, by a luck, that negative gives you what? Positive thing. But remember the correct path. I hope you understand this. Once you say that I is minus of dq by dt, this becomes minus of L d2q upon dt square, which is q by c. This is di by dt. I is already minus of dq by dt. So what is di by dt? This is d by dt of I. What is I? Minus of dq by dt. This is called second differentiation of q with respect to t. This di by dt becomes minus of L d2q upon dt square. That's how it is right. d2q upon dt square. That is second differentiation of q with respect to t. Now, many of you may think that this is something which is completely new or something like that, but it's not. This is something which you have been studying from class 11th and very beginning of class 11th. The very beginning you have been taught this. What is V? dx by dt, rate of change of displacement. Then what is A? dv by dt, rate of change of velocity. So what is A? d by dt of V, which is dx by dt. And therefore A is also called what? d2x upon dt square. I hope you remember this, that what is acceleration? First differentiation of velocity with respect to time, or second differentiation of displacement with respect to time. Now, I have introduced this part because we can solve this equation with the help of something which we have done again in 11th. Note down this much and then I will solve this equation. Well, I hope you have all seen this type of equation in 11th. A equals to minus of omega square x. This is the equation for simple harmonic motion. What is A? A is d2x upon dt square. And for this equation, x is A sine omega t plus phi. General equation of simple harmonic motion. When you integrate this, if you wish, I can give you the notes of simple harmonic motion. You can see how do we arrive at this result from this equation. But right now, I'll assume that you all know this equation ultimately gets you A sine omega t plus phi, and this is something which ultimately gives you the very first equation in today's lecture, y equals to A sine omega t minus kx. Right now, just remember that solution of this is x equals to A sine omega t plus phi. Why are we interested in solution of this? Because look here, this is what Q with a negative sign. Shift the negative sign here. X and the negative sign. That means if I write this equation in this form, If you write the equation in this form, d2q upon dt square, it is minus of q upon LC, which is equivalent to minus of 1 upon root LC whole square into Q. Something square times x. Something square times x. And therefore, first you have found the omega. What is omega? Omega is coming 1 upon root LC. I hope you remember this omega, 1 upon root LC. This was the resonating frequency. During resonance in LCR circuit, at this frequency, your peak value of current becomes maximum. This is the same omega, 1 upon root LC, which we have developed in this LC oscillation. What is the relation with this omega with that? We'll see that later. But now I can do what? I can simply write this equation in this form. Replace x with q, a with, what is a? Maximum of x. What is maximum of q? Q naught, maximum charge on the capacitor. Sine, I need omega, I already got it. 1 upon this plus phi. I'll find phi for you also. This is q equals to q naught sine omega t plus phi. At t equals to 0, when you close the switch, right when you close the switch, charge on the capacitor is maximum, and then gradually it decreases. At time t, charge becomes what? Q. But at the very beginning, when you close the switch, charge was what? Maximum. So you are saying that at t equals to 0, Q is Q naught. Now let's be fast. At t equals to 0, this is 0. Q is Q naught. Let me write it here. Q is Q naught sine omega t term, that is 0, phi. It gives us sine phi equals to 1. That means phi 0, omega t is 0, this term is 0, sine phi q naught 1, sine phi is 1, that means phi is coming what? 90 degrees. If phi is 90, charge q is q naught sine omega t plus pi by 2. What is interesting about this Q? Look, in LC oscillation, we have proved that charge Q is oscillating. Q is oscillating like this. If Q is oscillating with this frequency, if charge is oscillating, then it will produce what? An oscillating electric field. And that oscillating electric field is part of electromagnetic wave. If charge is oscillating, then current is also oscillating, and current produces what? Magnetic field. That magnetic field will also be oscillating. That gives you what? The magnetic field component. So this LC oscillation is nothing but a source of electromagnetic wave. Note down this much, and if you can get me function of I in terms of t, then write down that in the comment box. Note down this much. Let's see how do we find I. What was I? I is minus of dq by dt. What was I? I is for this particular setup minus of dq by dt. To differentiate this, this is coming minus of q naught. Differentiation of sign is what? Cos. Differentiation of sign is what? Cos omega t plus pi by 2, and take the omega part outside. Or you can simply write this q as q naught cos omega t. What is sine 90 plus theta? Cos theta. And what is differentiation of cos? Minus. That's the minus thing. So your I is coming minus of q naught omega sine omega t. Cos 90 plus theta is what? Sine theta. This q naught omega is the maximum current I naught. Sine of omega t. So I is coming minus of I naught sine omega t, and this is q, which is q naught cos omega t. What is I naught? What is I naught? I naught is q naught multiplied by omega. Omega. What is omega? Omega was 1 upon root LC. So what is the relationship between I, maximum current, and maximum charge? That relationship is coming I naught equals to q naught into 1 upon root LC. Now this relationship we could have obtained in just one line. Now look what that line is. But before that, differentiate the whole thing, write down this part. How could we have arrived at this result directly between maximum values? Initially, charge was present on the capacitor, Q naught. So what was the energy of the system? Energy of the system was half Q naught square upon C. At that time, there was no current in the inductor, 0. That's the energy of the system. After some time, all the charge in this capacitor becomes 0 because of discharging. At that moment, this inductor must have maximum current. When charge is 0, current in this inductor will be maximum. Why? So that we can conserve energy of the entire system. So when charge in the capacitor is 0, what is the energy of the inductor? Half L I naught square. Half and half cancel, take the root. This is Q naught upon root C, root L I naught, which is giving us I naught as Q naught divided by root C root L. This result. What is this? This is EOC or COE, conservation of energy. So everything which you saw so far is nothing but application of conservation of energy. Now why does it make sense? Because what is Lenz's law? Lenz's law, I hope you remember, is nothing but conservation of energy. What is Kirchhoff's second law? That is also an application of conservation of energy. So everything which we did so far, we can find the final result with the help of this simple energy conservation. When energy in the capacitor is maximum, energy in the inductor is zero. At some time, this. At some intermediate time, this will be happening. Half Q square by C, charge is Q, plus there will be some current flowing in the inductor. Energy of the inductor will be half Li square. This is at some intermediate time. At every time, your energy is what? Constant. So you could have arrived at the Kirchhoff's second equation by simply differentiating this term. If you differentiate this, differentiation should come zero because this part or this part, it's just a constant. 100, 0, 0, 100. This is something which is changing. 25, 75, 75, 25, 20, 80, 80, 20. This tells us what? That in the LC circuit, charge is oscillating, current is also oscillating, oscillating current is producing oscillating electric field, oscillating current is producing oscillating magnetic field, which together give us what? An electromagnetic wave. And therefore we say that LC oscillations are responsible for what? LC oscillation means oscillation of a charge. It provides us what? An electromagnetic wave. I'll just take 1 minute's time to draw the graph. Let's draw the graph between I and T and Q and T, and then rest we'll discuss in the next class. Meanwhile, if you can yourself plot a graph, then do it fast so that you can verify your answer. Q versus T. I versus T. What is I? Graph of sine with a negative sign. That's how you draw a graph of sine. Then draw these partitions. I hope you remember we have done similar thing in LCR circuits. Draw the partitions. All these partitions are at an interval of T by 4. Graph of Q is the graph of cos, and cos you know starts from this. This is the graph of Q. This is Q naught. This is minus of I naught. For this you can show I naught part. This is the minus I naught part. Note down this much and rest we'll see in the next class. Thank you very much.